All right, so this is the second day, Wednesday, April 19th, and in this lesson we're going to continue to solve inequalities, but in addition we're going to graph those inequalities, and we're going to write inequalities to represent given scenarios. So as before, you will do some classwork with me through the video, then you're going to do your independent work, and at the end you have an exit ticket that you need to turn in. So we're going to start with simple multi-step inequalities. And just like we solve an equation, we're going to solve that inequality. So if it's helpful for you to sort of draw a line, this is, of course, this is not a balancing beam because these are not equal. This side is going to be greater than or equal to this side, right? But if it's helpful for you to think about that the same way, you can. All right, so I want to start by isolating my variable, my x. So I'm going to subtract the 20 from both sides. I have a negative 20 and 4x. And then now, and I had a feeling that was going to happen, that this bar was going to get in the way. Now I want to divide by 4 on both sides. And this is the same thing we do when we're solving an equation, right? The only thing that's different here is that x is not just equal to negative 20. It is also greater than a negative 20. So I'm going to go ahead and graph this, and your graph has some nice intervals. I don't have those. I don't have the same thing. So I'm going to just create it. So I'm going to say negative 20, negative 19, negative 18. I don't know, that's enough. And it's going to be both equal to negative 20 and then all the values that are greater than negative 20. All right, so easy peasy lemon squeezy. This should be a sort of quick work that we do now. So now I want to do the same here. I want to isolate my m, and so I'm going to divide both sides by a negative. Now, what's different than this one where I subtracted by a negative, right? And then I divided by a positive, is that now I'm dividing by a negative sign. So what happens is that my inequality symbol switches. It is going to now be greater than 8, or rather 8 divided by negative 2 or negative 4. Because when I divide by a negative, in this case negative 2, my inequality then switches. So now I'm going to do the same thing. Let's say negative 4, negative 3, negative 2, and m is greater than negative 4, so I'm going to include negative 4. Well, I'm going to circle negative 4, but I'm not going to fill it in. It's not going to be included because it is not equal to negative 4. All right, so here I'm going to now isolate my variable, my y, by adding 6 to both sides. Y is, or sorry, I have 18. 3y is less than 18, and I'm dividing by a positive, so it does not change the position or the direction of the inequality. So y is then less than 6. So I'm going to circle the 6, draw my arrow, right? It doesn't include it. And here I am going to get my x by itself. Notice the x does not have a coefficient, so this is sort of like a one-step thing. I'm just going to add 2 to both sides. And so I have 7 is greater than or equal to x. So the one thing that's sort of tricky here is that what does that tell me about x? Well, x then is less than or equal to 7. So I do like that one because sometimes the inequality is written this way, but you're still looking at the variable. So you have to read it sort of from the variable and across. So it does include the 7 and all the values that are less than 7. Now we're going to quickly do these two problems, and let's see if I can move this so you can see a little better. Yeah, there we go. So we're going to start by, well, I'm going to read the scenarios, and then we're going to write an inequality to represent each statement or scenario below. So we have Zaire, who wants to apply to a minimum of 3 colleges and a maximum of 10 colleges. Use X to represent the number of colleges. So we know that X is between, well, we have our lowest value, which is 3. and our highest value, which is 10. So this is sort of a compound inequality. So 3 is, well, let's see, x is greater than 3, and it is less than 10, because 10 is the max and 3 is the least amount. All right, McKindy wants to spend at most 45 minutes, on his math homework each night. Use X to represent the number of minutes spent on math homework per night. So at most, what does that tell me? Does he spend 45 minutes? Yeah, he does. But he does not want to spend 46 minutes. So 45 minutes is included in this scenario. So I have X is at most 45. I know 45 is going to be my term, and it's greater than, right? This is the largest part. So X is less than or equal to 45 because he does not want to go over 46. Anything less than 45 would work. So I want to just quickly graph these two now that we've written them. And so we're going to graph these inequalities. And I'm not going to do a fantastic job of this graph, but that should be 10. And then let's say this is 1. So this is 2. And let's say that's 3. Yep, that'll work. That's fine with me. So now I know that I am going to put a circle around 3 and a circle around 10. And all of these values in between 3 and 10 are included in the number of colleges that Zaire will apply to. Here I have X is less than or equal to 45. So I'll put my 45 here, 46, 44, 43, why not? So I'm going to circle my 45. I'm going to actually include the 45, right? Because I have a bar underneath that tells me I'm going to include it. And then all the values less than 45. Now, if I wanted to talk about, like we did before, viable and non-viable solutions, can we spend negative time? No, right? We can't spend negative minutes. So I would say maybe -2 minutes is a non-viable solution. It doesn't make sense according to this scenario. Another one might be for Zaire, I might say -5 is a non-viable solution. Oh, well, that wouldn't even include because he doesn't have, it ends there. So it would only really work here, right? Where it would make sense, right? It is less than 45, but it wouldn't make sense. What could work here is something like 3.2. And we're really not getting specific on this, but 3.2 might not work because you can't apply to a fraction of a college. Right, but this graph for now works well for us. Okay, so now that you've watched the video, I want you to go ahead and complete the classwork and the exit ticket.